Good evening wherever you are in the world. Hope everyone's doing well. I'm just going to put everybody on mute just to get us started. Great. All right. Well, thank you so much for joining this free webinar for operations and maintenance here with the Offshore Wind Academy, as well as our wonderful speakers from GE, Vernova, and OWC. So today we're just going to do a small hour. I know the invitation said 45 minutes, but it's actually going to be closer to an hour. Hopefully that's okay for everyone. If not, we have the recorded session that we'll be posting later, so you can catch up on anything you missed. So we're going to be opening up a little bit with Cristina on the current challenges and the future solutions that we have coming up for operations and maintenance, which is very key these days to any developer or otherwise touching the wind farm strategy, given that it can take 25% or more of a total project cost. And then we're going to be rolling into the owner perspective from Cliff at OWC. And then I'll just close a little bit with a little bit more about the Academy for those who don't know about us, and a little bit more about how to get signed up for the course that we have coming up on May 19th and 20th. So without further ado, Cristina, can get started. And if anyone has any questions throughout the webinar, feel free to just raise your hand and or type the message in the Teams chat. So great. Off to you, Cristina.
Thank you, Sarah. So let me share my screen. So today we are going to do a small session here, just an introduction for the future course about facing the wind's current and future challenges in offshore. Just a small introduction about myself. I see some familiar faces here on the group, so some of them you know me already. So my name is Cristina. I'm currently working as a product service engineer and blade project manager. I've been in the energy sector for the last 13 years. I started in oil and gas, then I moved to gas turbines, steam turbines, generators, so combined cycle within GE Vernova, and then I moved to offshore wind 11 years ago. So along my career, I had developed a strong willingness to solve problems, to be frontline with the team, to support services department in order to accomplish and to bring successful campaigns in operations and maintenance, because they are meant to maintain the fleet of the offshore wind turbines for 25 years. So therefore, it's a long run assignment and long-term assignment, and with many challenges along the way. So that's what passionates me about my daily job. So to have a direct impact within the teams when we are going offshore. So when I would like here to start with some of the problems focused on the blades. So how we are maintaining the blades during the operations and maintenance, because as you might know, the blades can be the greatest challenge here because they are manufactured with composite materials. They are also made with hybrid, with carbon glass fibers. So those are brittle materials and they are susceptible to many damages. For example, lightning strike bypasses or any other meteorological impact. When we are talking about wind farms that where we have typhoon season, this is a very challenging environment. Therefore, maintaining a good strategy, not only to repair, but also to audit, to monitor, to inspect regularly these kind of assets is something key for the good health of our wind farm. Additionally, nowadays we are introducing new tools, artificial intelligence, and drones are facilitating our life massively, because in the past, these kind of inspections were conducted mainly up tower by ropes. Nowadays, we are always flying drone, and that they are autonomous drones. Therefore, we can have a full mapping of the full length of the blade. And what's the ideal periodicity? Nowadays, we are in a conservative approach, and we are doing every year. So I know that our homologs from onshore, they don't do so many inspections up tower, but we in offshore wind, we have more constraints. Therefore, we follow this path that is more conservative, but it gives us better results and more reliable data. So Managing a blade fleet requires exactly the same discipline as the rest of the asset across the wind farm. So the blades are a sensitive component. Then we will see in terms of component failure and damages, which is the more recurrent one. And this means that there is a huge added value by incorporating these inspections that need to be conducted with a periodicity of 12 months roundabout, because we can improve how our blades are behaving if there is any kind of minor defects, and the ultimate goal is to avoid any kind of catastrophic damage that will incur to a blade exchange. You know, exchanging a blade is going to be a massive operation that will need jackup vessel. Therefore, we need to optimize and to inspect and to repair on time to avoid this kind of larger stop of the turbine and major operations. For example, in our turbines, for example, in the Haliad 150, I'm talking about GE Vernova technology, 6 megawatts. This kind of drone campaign have helped us to shorten campaigns and improving accuracy, meaning that we are not stopping turbines additionally for extra rope access inspections, but we are monitoring them by the drone annually, and then with the database we can post-process these results, and with that we can create the plan of the repair for the following spring campaign. I would like to bring here what are the best practices in blade fleet management. Here on the right side, you can see a Heisenhower matrix. With this matrix, if we follow it up, we can also plan properly what are important and urgent, so tasks that we need to do immediately, or tasks that are important but not urgent, so therefore we will schedule them for the next campaign, meaning from spring we are starting our campaigns here in Europe from April up to end of September. And if the task is urgent but not important, we might be able to delegate, meaning that maybe it's not a priority to conduct the repair and the intervention at this particular time, but we can postpone it for a later moment. And in case that is not important or not urgent, we are not gonna bother about it, so we will just not take care about it. So for example, when we are talking about monitoring rotor blade outer inspection, so key part, the drone that we I mentioned before, it could be a second intervention in the case that we have doubts, because we know that the artificial intelligence is not perfect. Sometimes there could be some poor quality pictures, or there could be some deviation, so we don't know if the defect is a real defect or what is the depth. When we see a puncture that is coming from a line strike bypass, we cannot know how deep it is. So in that scenario, we need to send still a rope access team in order to do a deeper analysis. And these kind of tools, as we mentioned before, artificial intelligence, in order to do the image recognition, to classify all the pictures, and also the control monitoring system, SCADA data, those other sensors are going to give us also some kind of added value in our diagnosis. And this frequency is implemented or is given by the manufacturer itself. When we need to do an intervention by rope access of a platform, this is in the case of having a major event, meaning that when the intervention with the damage is larger, we are not going to execute this kind of repair on rope access, because this will take too long time. We might also compromise the quality of our repair, so this our intervention won't be successful. Therefore, in the introduction of this platform for blade repairs brings us also some benefits about these kind of interventions. And this can also give us an advantage in terms of weather. You know, when we are operating in offshore wind turbines, we are very weather dependent. What does it mean? We cannot have temperatures of 18 degrees Celsius that you need to do a normal polyester blade repair, because the temperatures are usually lower. The dew point also, it could be a conflict, the moisture in the ambient. Therefore, when you have a setup like a shelter from a platform, that could be be also beneficial for your repair because you will be able to control that environment to execute the repair. And then when we are doing a major exchange component, there are scenarios when we cannot avoid that. So then it requires cranes, offshore vessels, like jackup vessels, so heavy logistics. But in some cases, there is no other way around. So this is the latest stage when we cannot avoid it by monitoring, by doing the proper intervention, by a platform. We just maybe need to exchange the blade, and this will incur in a larger cost into the project. Best practice. For example, here, following, as we mentioned before, the Eisenhower matrix, important, for example, would be major cracks. If we can see any kind of leading edge or trailing edge cracks that are very common, could be a catastrophic failure later on if we don't repair on time. Lining damage, again, we need to assess as soon as we have detected it. By precaution, we stop the turbine, we assess it, and then we give a recommendation if the turbine can run in the way it is, or if we need to implement at least a temporary repair or a final repair. As well, any kind of detached cells. In our case, our blades are manufactured with two molds, so therefore they are bonding on leading edge and trailing edge. Therefore, in case that there are some deviations from manufacturing, that could happen during the first years of operation, and that could be also one indication of failure. Or safety critical defects, when the parts where they have a lot of flexion on the blades, they can propagate quickly. So we need to analyze any kind of fatigue lines, for example, and their propagation. When we are not seeing something that is not urgent and we can schedule that and plan ahead, so not to repair immediately, could be for the leading edge erosion. We know that we are applying nowadays in offshore, it is a recurrent practice to apply any kind of protection on the leading edge, like for example PPT tape or LA shell from soft shell, or different technologies, ProBlade Ultra from LM. There are different technologies, but we know there is a progression on the erosion on this component, meaning that their lifetime is shorter of the 25 years lifetime that the blades are expected to last on the fleet. Therefore, we know that at some point we will need to plan a repair, and it's important to incorporate that in our operations and maintenance schedule, because otherwise there will be surprises and we won't have the right budget allocated to do this kind of repair. Therefore, it's important to have it in mind and to plan it accordingly. Also, minor laminate cracks. This is something to audit and to monitor, because sometimes the cracks could be just affecting on the top layer, so the gel coat. So we need to analyze, is this deep enough? Is this something that we need to be worried about, or is this just superficial and we just need to monitor as a minor crack? And to plan rope access or platform repair. Things that could be needed to monitor closely. So some cosmetic. Yeah, there was a question here.
No, I think it was just a background noise.
Okay, thank you. So to monitor closely, there was some inspection flags, as we mentioned, gel cups. There could be some chips, or also openings in the trailing edge that could be stable. So we need to recurrently monitor them in order to see propagation. If there is no propagation, we can consider that is not important and we don't need to repair it at this interval, but we can postpone it. And surface discoloration, sometimes some coatings are not fully UV resistant, therefore we can see some yellowiness or superficial scratches. Those scratches are important if they happen at the time of the installation. At that time, it's really important to do a full mapping of the blade, because with the blade eagle seal, sometimes we have weakness and damages that could be important. But in the case that are minor superficial ones, we can just defer them, or back contaminations and stains, those can be assessed during the next inspection cycle. And also something that is helping us, because nowadays we are utilizing artificial intelligence everywhere. We are using data-driven operations and maintenance for performance optimization tools, and this is key. For example, here we are having on our blades individual pitch controller. This system let us adjust the pitch angle of each blade in real time based on wind speed, direction, and loads condition. Why this parameter is key is because in case of failure, we are going to reduce the loads not only on the blades, but also on the rotor, also on the tower. So therefore, this is helping us to maintain a good health of our turbine. If we were not controlling them individually, if we cannot modify the angle of each blade, there will be a higher risk. Therefore, this kind of systems is helping us to enable control and efficiency in our asset. Additionally, in the long term, we are going to reduce fatigue loss. This is beneficial for the long lasting of the turbines, the 25 years lifetime that they are manufactured for. Sometimes we are doing some studies in order to enlarge this lifetime. So this reduction of the fatigue loss in hub, in tower, is also key for this development of the turbines or the wind farm for longer period of time. As well, one key parameter is to optimize the power output. That for all the operators and OEMs is key. So to maximize how many megawatts we are producing. Therefore, optimizing this pitch angle will increase the turbine's energy capture, and we can also protect them in case that we have a strong wind, meaning that it's not only to optimize the maximum capacity that we can produce, but also in the case of having any kind of turbulences or some storms, we can also reduce the amount of wind that we are capturing here in order to protect our assets. And again, this IPC helps to prolong the lifespan of the turbine, reducing maintenance costs, and end of all, to reduce also the downtime. So here in our operations and maintenance plan, the key part is how to reduce the downtime, because there will be some LD, some penalizations that we will need to cover in case that we are not producing megawatts because of low availability of the turbines. And also something that we are worried about is about the early operation stage failures, meaning that during the first years of operation, we can see some kind of extra manufacturing issues or extra erosion on the leading edge, or lightning strikes, or also we need to mitigate or to solve all those transportation or installation damages. So those defects are happening more regularly during the first years of operation, and we need to take care about the material selection, the design details, or also the environmental concerns. Sometimes, even if before building a wind farm, there is conducted a full mapping of the weather parameters, meaning that we assess what is the highest likelihood of thunderstorms, of lightning strikes in each region of the wind farm, in order to have some precautions, so to monitor better the turbines that are allocated in the areas with higher likelihood of lightning strike. But sometimes we are learning also by installing it and witnessing the failures. So that's why in the first years of operations, we do usually more inspections more recurrently, and we try to solve all kind of transportation or installation damages that can have happened during the installation phase. Additionally, some technologies are evolving. For example, the leading edge protection. We know that the market has been evolving quite drastically, because the first solutions, they gave a coverage of around about 3 years. So 3 years for a leading edge protection that is covering at least 17 meters of blade is not something acceptable from the operations and maintenance condition, because then we will waste a lot of time doing this kind of repairs. Therefore, we have been modifying that and upgrading these kind of technologies to longer lasting solutions. For example, we have a better solution, longer lasting in the market, ProBlade Ultra or Polytech shells that are longer lasting solutions. Additionally, depending on the sites and due to the dependency of low clouds, we can observe many lightning strike damages that have been bypassing the receptors. Those blades can have monoreceptors just on the tip or multiple receptors along the blades, like the new blades of 107 meters, because when we are introducing carbon glass fiber in these kind of blades, they are more sensitive to lightning strike bypass because they conduct better. Therefore, they need to have more protection, but we need also to assess better in case of damage, how urgent is to bring the repair here. So these kind of defects are quite often, and they are something to witness more frequently in the beginning of the installation of the wind farm. Here, I just wanted to break down and to bring some numbers about how those early stage operations can have an impact. So in the past, when we were having a solution, like we mentioned, the 3M tape first generation, this is not anymore in the market, so we have upgraded them. We have a lifespan in between 3 to 3.7 years. This is not really acceptable, as we mentioned, because when we are having blades that are spinning at 91 meters per second at tip speed, this is gonna get eroded very drastically and very rapidly. So this was the picture after 3 years of operation, and we were forced to exchange them to bring some solution. And this repair, depending on how we are incorporating the solution, could take longer time. For example, we witnessed that the optimal way to perform it when we have many meters, so up to 5 to 10 meters repair, it was better to do by a platform, because otherwise by rope access we were having run about to 60 to 70% downtime. So time that the technicians were there in the turbine or in the vessel, and they could not execute any kind of repair because of the weather. And here we have some numbers about 50% of the blades. They had an advantage of being retrofitted in the 4th year of operation to avoid 15 to 30% extra cost. So those are the numbers, the KPIs that we could economize if we are doing this proactive campaign with our blades, meaning not waiting until we have the blades fully eroded, but prioritizing this kind of recurrent repairs upfront just to economize this 30% that we can have, that we can save in this operation. And strategies for optimized fleet maintenance. So we know that not every fleet can be treated in the same way. So we need to know well our environment. We need to learn the risk-based prioritization, focus on the defects that they have the greatest impact, or also based on production and safety concerns. For us, it's safety first. So meaning if there is any kind of risk of drop objects that could have any kind of damage to the people and going to do the maintenance in the turbines, that's our first goal. And also the safety for the turbine. So we need, that's why to bring this inspection to have this good understanding about our asset. And how we are doing this intervention. So we have a map. This is basically applicable for the market in Europe, because when we are talking about other regions like Asia, the map could differ and could be a little bit different. So here we are starting around about March or April, and we are ending our campaigns in September. But for example, the drone inspection has quite a narrowed slot of time, because we want to have the data early enough to then be able to utilize this knowledge and those findings in the months of July, August to bring the repair remedy. And also to know that the blades are the campaigns that are having more constraints for doing the preventive maintenance on hub or on tower or nacelle. We have longer period of time that we can deploy the teams, but for the blades use is very limited, the amount of time that we have to bring the solution here in offshore. And what are the root causes of blade failures? So here I just wanted to break down what are the impact for each kind of component. So we know that the blades represent in total around about 29% of turbine failures per year, while in offshore is 4.8 failures of turbine per year. We know that the root causes are due to fatigue. That's why we mentioned before that reducing the loads is very important to reduce the fatigue loads that they are submitted. The lining strikes is very critical because they can burn our laminate and they can create a hole or even a crack in the blade. And the leading edge erosion is contributing up to 20% of those blade failures, or having any kind of cracks at the root of the blade or at the tip, they are 12%. So we need to avoid also minor defects, or at least monitor them to avoid getting into catastrophic failures. And another consideration is about manufacturing issues. That's why our quality and control system is very strict nowadays, because we need to avoid any kind of deviation coming from manufacturing. So doing an inspection of a blade on the floor or in a factory, it costs 10 times less than doing that operation offshore. Therefore, we are prioritizing any kind of investigation before shipping the blades, before load out, to avoid any kind of deviation. And of course, after installation, about this problematic that we mentioned about transportation or installation, that there is always a risk of having some defects. So this is something that we are also monitoring, how the blades are afterwards. And some other topic here that I think is important for the forum is about subcontractor selection strategies. So what is better, to bring a repair in operations and maintenance in-house, or to do some subcontractors? So it depends. So a balance here would be a split. So doing a lump sum contract with some subcontractors, could be efficient, but sometimes we are losing overview, and the problem is about the shared knowledge or the lack of knowledge. Like when people are exchanging teams, we need to start again with when we start a new maintenance campaign. So the ideal numbers would be at least, or well, the minimum numbers would be 20-30% in-house and 70-80% subcontracted. Why this amount of subcontractors? Because we are working with teams that are seasonable, meaning that we are not deploying all our teams during the full year, but we are conducting the operations and maintenance during the season. That's why for us in Vernova, we are having round about these kind of numbers, but we need to ensure that we have the key people also in-house. The key people should be the contractor's representative, the site manager, the quality inspector, the planners as well, the warehouse manager, and also people controlling the documentation and the instruction, the field instructions. Because if we are not ensuring this kind of people, key people in the fleet, we can have also some deviation or some loose competencies, and we can have not the full overview for the next campaign. So it's critical also to maintain some kind of roles in-house.
Cristina, just being mindful of time, if you could just,
Sure,
go through
yes.
a couple of slides. Thank you.
It was just about the end, like how can we build the right teams? So internal teams keep the knowledge inside the company, and they could offer more flexibility, and they could be deployed quicker. But again, we are talking about seasonable workers, so therefore some advantage of having this manpower subcontracted, about 70-80% of the people, that could have also some impact in our budget. So this is just the last point about how they work: in-house team, outsourced team, maintaining knowledge, more flexibility, and then we need to cover the trainings and the certificates that are also expensive. But on the other hand, for the outsourced teams, there is no extra cost during the off-season, during all the months of autumn, also winter when we let the turbines running, and they could be also some more specialized manpower. That's also an advantage, that they have additional knowledge that they can bring in a case, for example, of major exchange components. They could be people more knowledgeable about transportation installations, so therefore this is also an advantage. And the conclusions and takeaways here about this course and what we can bring into how can we develop better this operations and maintenance setup is that every fleet is different. So we need to define the strategies, and we need to be also as much as possible data driven and tailored to the specific site conditions. And we need to balance the preventive actions with cost efficiency, to choose partners or subcontractors wisely, and to invest in the internal capabilities where it makes sense. And if we combine the lessons learned from the field with this strong collaboration, in-house and outsourced people, we can improve the reliability of our offshore fleets. So thank you so much.
Yeah, thank you so much, Cristina. I really thought the Eisenhower matrix was quite interesting. It was a nice tool. Great. Yes. All right, so that's a nice deep dive into blades, Christina's specialty. So you'll see more like that throughout the course as we cover all the major components of the wind farm. So, all right, so let's just keep moving along just so we have time for all the presentations. So Cliff, I'm going to pull you in now to get going. And then if you have any questions though in the meantime, please type them into the Teams chat. So we can make sure that we get to them at the end of the presentations. Thank you.
Thank you, Sarah. Yes, hello everyone. So I'll aim to take about 20 minutes today to allow Sarah to explain a bit more about the Offshore Wind Academy and the courses available to everybody. As Cristina said, there are many elements we face as owners today, and to set the scene, I'll start by saying, most offshore wind assets operating today are doing exactly what they were designed to do. The problem is they were designed for a world that no longer exists. And the consequences of that gap now sit squarely with the owners in operations. Three things which typically happened sporadically have sort of come together and are sort of acting at once. And that's costs are moving quickly, revenues aren't going up in any way, and risks are shifting back to the owners as the warranties end. And the issues begin to stack up. So the costs, performance, supply chain, geopolitics, it's all happened at the same time and within the last month in some cases. So the owners are really having to deal with very reactive responses to how sites are now operating. A bit about me. I work on the owner side of the offshore wind assets, where performance stops being a model and it becomes now a set of decisions at board level. So it's no longer on paper, it's real world scenarios that we face every day. That includes advising boards, shareholders on how assets behave once they're built, not just how they look in a model. I've spent around 25 years across development, construction, operations, including senior roles at Ørsted and Octopus, and I've represented a number of operational assets at board level. And I'm currently on Hornsea 3, representing the investor there to see the site through construction and into operation. That is the single biggest wind farm in the world currently. Once it's completed, it'll be 2.9 gigawatts of power. So today, it isn't a theory. It's what owners and boards are dealing with right now.
Okay, I found this on the web for what owners and boys are dealing.
Excuse us, Siri. So here, none of these forces are new. What's new is how they stack up and how they land on operations. Inflation has embedded itself into vessels, logistics, and labour. Higher rates have made resilience more valuable than upside. Geopolitics shows up as delays, insurance, fuel, spares, and supply chains are global, which means disruption travels fast. So when you look at what's happening in the Gulf currently, that is having effects either now or in the future on how assets will be operated. And typically we'll see whatever's happening now could happen, translate into effects nearer to the winter period, which becomes then more challenging in an operational space. So together, the operating environment has changed and the owners feel it first. For a long time, offshore wind was positioned as and largely accepted as low risk infrastructure. Offshore wind hasn't become more risky. Investors' expectations have become more realistic. The questions have moved from what's the yield to what happens when the assumptions are tested. There's less tolerance for surprises and more focus on operational reality. What's changed isn't the fundamentals, but the confidence in how predictable everything really is once the assets are operating. Investors are looking beyond the headline availability figures, where if the sites were typically operating at 99%, now we're looking on some sites at the low 90s or the high 80s, and they're searching for more questions. I've been appointed in recent roles for this very need for investors. They want to understand more of the practical side of the assets. They want to understand where the risks sit, particularly once projects have moved beyond warranty, when contracts are tested and when cost pressures start to bite. There's also less tolerance for surprises, not because investors expect perfection, but because they expect risks to be understood, communicated early, and actively managed, and not discovered late, and not adding extra stresses in an ongoing asset. The connection between how projects are awarded and what owners experience many years later is important. In the UK, the funding mechanisms, feed-in tariffs, renewal obligation certificates, contracts for difference have been very effective in delivering renewables at scale. It provides revenue certainty, which has been attractive to investors and has supported rapid deployment. But that certainty also comes with trade-offs. The strike prices are set through highly competitive auctions, often based on assumptions made several years before the assets are operating. Once the auction is over, the spreadsheet stops protecting you. Once projects are built, those assumptions are largely locked in, while the operating environment continues to change. So what does this mean for owners? Revenue is stabilized, but exposure to cost, performance, and delivery risk keeps evolving. Over time, a growing share of uncertainty concentrates with owners and the asset managers that look after the owners. The shift, it really shows up clearly in boardrooms. When we talk about changing investor expectations, what does that sound like in practice? As you can see here on the slide, how are we exposed to rising O&M and logistics costs? What happens if availability is lower than the model assumed? These are all natural questions that follow when risk moves back to the owner. But you notice what's changed? The question is no longer what's the upside. It's always focusing on the downside. So down to the operational reality, the stresses show up in three places. First, incentives drift. Variable fees make sense at contract signature, then align pay to performance. but incentives that worked at financial close often misfire in year 10 because the risk drivers change: access, failures, spares, people, vessels. Cristina showed some good examples of the turbines. A lot of those were unexpected, not modeled, and then owners have to react and deal with those situations. Second is disruption becomes normalized. It becomes normal. Force majeure is used to be a legal clause that you rarely touched. Before COVID, it wasn't even ever discussed. It was in the contract, but very rarely was it picked up. Now force majeure is used as a commonplace to set a legal scene between OEMs, contractors, and the owners. It is typically a flag in the sand, and that is very relevant for today. As I mentioned with the Gulf, a lot of those suppliers that are bringing materials from Asia are having to either go through the Suez or were doing stop-offs in the Gulf and are potentially stuck now in the Strait of Hormuz. That's where these force majeures have their place. It is obviously very difficult for the OEMs and for the contractors to prove, and it means that there's a lot of work to be undertaken in the force majeure scenarios, but they are certainly being used more regularly than we have seen before. Thirdly, it's the cost base has been completely reset, and that again was a sign of COVID. We saw that prices had come down through the lowered cost of energy. As soon as COVID hit, and as soon as we had these challenges of moving people, moving materials, inflation set in, and it's not really reset back to those numbers. It's now a new baseline with these costs. So vessels, labor, lead times are structurally higher and structurally tighter. There are very limited margins of error. So revenue stays stable, but uncertainty moves, and most of it lands again with the owners. I would say it's not all doom and gloom. I know I've given you a lot here today. The good news is offshore wind isn't broken. The environment has changed, and that means we have to adapt. We have to embrace technology that's coming towards us. Cristina also mentioned AI. You will find that that is the way of working in the coming years. There will be a lot more of using tools differently. It's no longer spreadsheets, it's AI interpreting those spreadsheets. So we end up being more resilient. The owners are doing their best of making these 4 shifts. So they're resetting expectations. They're not being over ambitious. They're prioritizing resilience over best case yield. They're re-engaging with the operating risk to revisit what that risk now looks like. And it's enabling early decisions while options still exist. So you are working through multiple scenarios and being open because, as I demonstrated earlier, the owners are becoming cleverer and understand the assets more and more, and they are bringing in experts to provide those that are typically fund houses that are providing the capital. They are hiring experts to be able to provide their eyes and ears on the board seats. So for me as an asset manager and operators, the asset management matters more in this environment because decisions create the outcome. The value today is protected by early decisions, but it's not perfect information. So the shift is anticipate risk earlier, decide faster, and act with purpose, and communicate the uncertainty clearly enough that the boards can support you. There are a lot of questions now around how can we support the operators? How can we support the asset managers? What do you need from the board to operate in this new environment? So the goal isn't perfect foresight, it's better decisions sooner. With that, I will just quickly explain what to expect from the two-day event that is being held on the 19th and 20th of May. We'll be looking at early O&M strategy, taking all of these comments on board that what owners are now looking for. So we'll go from early O&M strategy to long-term operations. We'll be looking at the contracts and the risks associated with those, so managing contracts, incentives, and the risk in practice. The component level management, as Cristina touched on, components are failing, some more than others and some not expected. So we're looking at component level maintenance and failure patterns. How can AI help with that? The technology that is out there with the agents that are being developed allow you to understand these failure patterns much sooner, which allows you to plan for future campaigns. And then we'll be looking at developing new best practice for today's conditions. So practical approaches, how owners are managing that, how asset managers are then responding, and how the operators can apply it immediately. Thank you. And I'll hand it back to Sarah.
Great. Thank you so much, Cliff. Yes, this was really great. It's definitely shocking, like you're saying, but it's quite interesting to see this. Okay, the rules have changed in a way, right? But the actual approach just has to shift along with it effectively in this world that has gotten a little bit crazy in the last couple of years. So no matter where you work in the O&M industry, it's important to understand this context, I think. So that's really nice. Thank you. Okay, so I'll just do one very quick overview of the Academy, and then we can open it up for questions. So, for those of you who don't know us, Offshore Wind Academy was built with several of the large players along the way. It was created to fill this gap for office-based personnel that don't have access to specific niche offshore wind training. There's plenty of trainings out there for technicians, but not so much for us who sit behind a screen each day. So many of these players got together and decided that we needed to do something about it. And here we are today, the Offshore Wind Academy, executing courses across the world. Like even Cristina and Cliff went to Taiwan last year to give an operations and maintenance course. So we've been everywhere. And the way that we do it is we build these courses through not just, let's say, myself or someone else who works at the Academy being involved in the development. We add more the educational element of things, but we bring in experts that are really top of the field, like GE and like OWC, who are able to give you the most up-to-date information about what the real challenges are, what are the real solutions out there. So it's this experts teaching experts model in the end. So just like I said here, and then they tend to be normally live 1 to 3 day courses because we understand that you're a busy professional and you need to get information in a much faster, more streamlined manner. So this course coming up is going to be 2 days and it's going to be online, so you can access from anywhere in the world. We also do have some recorded courses available, as well as some self-paced courses for select topics. And they're always going to be able to this mix of theory and practical, like you've just seen today. I think Cristina and Cliff did a great job with showing a couple of real studies, as well as talking a little bit more about the theory side, and a little bit more about how we move on from here. And they have some activities, I remember, as well. So get ready to get hands-on if you do decide to join us. And we then take all of the feedback from the courses and use it to improve from course to course. So if you've been in a previous course of ours, we've now adjusted it based on any previous feedback or what we've been noticing has been going on in the market. And that's how we stay up to date here at the Academy to make sure that you are getting the most recent information possible to make us the leading global knowledge and networking hub of offshore wind. So Basically, we've trained over 600 people in the last 2 years. You see a couple of pictures here from some of our courses that we've done. This one on the left is from a transmission workshop that we did in Stafford, UK, also with GE Vernova, different instructors though. In the middle, we had a blade workshop back in Massachusetts to look into blade repair methods, diagnosis and repair. And then you see robotics on the side, which is to show that we have online courses like you're going to be seeing if you join us for operations and maintenance coming up on May 19th and 20th. So we've gotten really good feedback in case you need to be sold a little bit more, but it's helped a lot of people with supporting the strategic business of their businesses and invaluable experiences to gain lots of knowledge and understanding how they can move forward with success. In their own companies or in their own careers as well, because we have several individuals who are just looking to learn and get more involved in the industry that also come to us. So that's it about the Academy. Let me just really quickly pull up the page to talk a little bit more about how you can get signed up if you're interested. Great. Okay, so you can find on our webpage at offshorewind-academy.com, or if you just type Offshore Wind Academy, we should pop up first. And you'll find this operations and maintenance page here. If you want to get enrolled, super easy, just the button right at the top. If you are a little bit scared of the price, we do offer some financial assistance. We offer a limited amount of scholarships though, so if you're really interested in getting a seat in the course, make sure that you directly enroll. And then you can check out the rest of the session. So Cliff touched upon it, but there's a lot more information in here, including the course FAQ if for in case you need to present information in a much more short format, slightly more visual format for someone who is more of a decision maker in your company. So a little bit more about the project objectives, what the course is designed for, and how's it different than O&M trainings, for example. If you need anything, you can always find us at info@offshorewind-academy.com. You can reach out to us on LinkedIn, whatever is easiest for you. So I hope that you will be able to join us on May 19th and 20th and hear a lot more from Cliff and Cristina, because the whole goal of these courses and the whole uniqueness is that we have both an OEM and an owner present. So you'll be getting an extremely unique view and operations and maintenance that will make you a much more well-rounded business and or individual. So that's all from our side. Does anyone have any questions before we close the webinar for today? Whether it's about the course or about anything that Cristina and Cliff have mentioned. Otherwise, you can save them for the course when we see you on May. Okay. Yes, did we have one?
Thank you, Sarah. Enough.
Okay, great. Thank you very much. And thank you so much, Cristina and Cliff, for your time as well. So we hope to see everyone at the course on May 19th and 20th. So have a good rest of your day.
Thank you, Sarah. Thank you, Cliff. Have a nice day. And thank you for all the attendees.
Yes, thank you. Goodbye.
Thank you.